Okay, so we're going to find acceleration of this box. We got force of kinetic is 100 newtons, box is 13 kilograms. The desk is at 74 degrees. So the first thing it tells us to do is we're going to find the theta of the book. And so we're going to find the angle that this book is falling. If this is at 74 degrees, if we were to turn this into a triangle, so if you were to go here and then up, this would make a triangle, right? So we go straight down here, triangle. This is at 74 degrees. This would be 90 degrees, and that's going to give us 164 degrees when we add our 90 degrees plus 74 degrees. That gives us 164 degrees, and a triangle is equal to 180 degrees, right? So if the whole thing is supposed to be 180 degrees, there's a difference of 16 degrees, so that has to be what our theta is. So I'm going to write that as one of our givens right here. Givens, theta is equal to 16 degrees. I'll also write some of this information down. So we got force of kinetic is 100 newtons. Should be in the way. And then we have the mass of the book is 13 kilograms. And we know acceleration in the y direction is going to be negative 9.81 meters per second squared. So we got all that information. I'm actually going to erase this real quick after we got theta, just because it kind of makes it a little messy. So those are all our givens now that we found theta. And so step one's done. We're going to now turn our force normal into your y-axis. So sorry, what I meant to say is you should draw all your forces acting on this box first. So I'm going to draw those. We of course would have force of gravity. So going downward, we're going to have Fg. So here's our force of gravity. And then going perpendicular to the surface of contact. So it's at an angle, so it's actually going to be angled up. So this is our force normal. And those are the three forces acting on the box. And so it says turn force normal into your y-axis. So what I'm going to do, I'm going to take this force normal and I'm going to extend it. And this now became my y-axis. Okay, if this is now my y-axis, notice how force of kinetic, it's going straight down and then it meets here. This would be a 90-degree angle, which means force of kinetic has to be our x-axis. So now we have an x-axis and a y-axis. Okay, it's kind of like we just took the graph and we just turned it a little bit. Sorry, my drawing's not very good that you can see it, but hopefully you can realize this is your y-axis. This is now our x-axis. This is not y or x. It's actually going in both directions. So it's actually both. And so what we're going to do with FG is we are actually going to make it into a triangle, because notice it's not going x or y, it's going both. So it's actually a resultant. So we're going to travel down here, draw this perpendicular. So now this is our force of gravity in the x direction, and this is the force of gravity in the y direction. So now we have those two. That's breaking down this force of gravity, because it's not going in one direction, it's going in two directions. Then we got FGY, FGX, force normal. Okay, so now we got all those. A question is, does it move in the y direction? So will this book move towards the force normal or towards the ground? And that's, remember, using this y-axis, the book is not going to go through the table, and it's probably not going to fly in the air. So that actually tells us something important. It tells us that the net force in the y direction, the total force in the y direction, has to equal 0 newtons. Because there can't be a force, because it's not going to move up and it's not going to move down. It can move left or right, but it won't move up or down. And so we got step 1 through 3 done. Now find all forces. Fg turns into Fg of x and Fg of y. Sorry, I kind of jumped the gun on that, but now we have Fg of x, Fg of y. So we're going to find all these forces. So we got force of gravity is what I'd start with. Then we got Fg of x Then we have FGY. Then we have force normal. We're going to find all those forces. So first we need to find force of gravity. Equation I would use, we have the mass, so I would just do Fg is equal to mass times acceleration. We know acceleration in the y direction is gravity, so that's what's accelerating it. So Fg equals 13 kilograms times negative 9.81 meters per second squared. And this is going to give us force of gravity of 122.5 newtons, I believe. Notice it's going downward, so it would be negative. I'm not doing it negative just because this said negative. I'm doing it because the direction is actually negative. That's something to point out, especially for later. So, for example, when we do Fg of x, the theta, remember we'd be using the theta of the book, so we already found that. That was 16 degrees. So in order to find the components of this triangle, we can use cosine to find x, sine to find y, and we're going to use Fg as our hypotenuse. So essentially, if you want to break this triangle down so it maybe looks a little bit neater, it would kind of look like this, where this is Fg, this is Fg of x, and this is Fg of y. If that's better for you to see, this would be 16 degrees, and we already have this value, so we're going to do cosine to find x. So we're going to do cosine 16 degrees times our Fg, which is 122.5 newtons, and this will give us our Fg of x. Which will be 118 newtons. Oh shoot, this should have been 127.5, so I'll change that to 127.5, and that's going to change this. I apologize. 16 times 127.5. 122.5. That's where I got that number from. Fg of x is going to equal that, so this should have been a 7. This should be 127.5. Okay, so Fg of x. Notice Fg of x was going which way? It's going to the right in both pictures. I did that on purpose, so that should be positive. Now we're going to find Fg of y, and Fg of y is going to equal sine, because it's right here, so it'll be sine theta times hypotenuse. Fg of y is going to equal sine 16 degrees times 127.5 newtons. Fg of y is going to equal sine 16 times 35 newtons. Notice it's going down, so it's going to be negative. I almost had